Hey everyone, welcome to this video. Let's talk about LLM reasoning models. So what is a reasoning model? As the name suggests, reasoning models are good at questions that require reasoning, such as math or logic. Like in this example problem here. Kevin is a waiter that makes a base salary of $10 an hour. Today, Kevin worked a standard 8-hour shift and then worked 2 hours of overtime, which is 1.5 times pay. Kevin also received two massive tips of $100 each. How much money did Kevin make today? Let's next talk about chain of thought prompting. We have learned so far that LLMs are trained to be good at next word prediction, which then leads to the LLM having general knowledge. However, this does not necessarily mean the LLM will be good at reasoning. However, you can make the LLM better at reasoning by directly telling it something similar to explain all the steps you will do to reach your answer. So here's our prompt to the model before, and then afterwards we will add the last bolded sentence of explain all the steps you will do to reach your answer. And once we tell the LLM to explain the steps it will do, it does so, right? It says, okay, first I'm going to do 8 times 10, then 2 times 15, then 2 times 100, and then add those up to $310. And by just adding, explain all the steps you will do to reach your answer, we have pushed the LLM to think and reason. And chain of thought prompting can lead to more correct answers. By just adding, explain all the steps you will do to reach your answer, we have pushed the LLM to think and reason. This in turn can lead to the LLM having much more correct answers on reasoning questions such as math or logic. Wait, what? Did you just say, Kevin, that by just adding explain all the steps you will do to reach your answer or chain of thought prompting, the LLM can have more correct answers and therefore better performance? That almost seems too good to be true. That almost sounds like magic. So what's happening here? Well, I want you to pause the video and see if you can solve this problem for yourself. Now, what you most likely did to solve this problem by yourself is you broke it down into smaller problems or smaller steps. You most likely did, okay, I'll do 8 times 10 plus 2 times 15 plus 2 times 100 equals 310. What you did was you broke this problem into smaller problems that are easier to solve. And what happens is that chain of thought prompting will do the same thing. It will push the LLM to break down the problem into smaller and easier problems, similar to what humans do, which can lead to the LLM having more correct answers and therefore better performance. So it's not magic, right? It's just you're pushing the LLM to break into smaller problems that are easier to solve. But what if instead of using chain of thought prompting to push the LLM to think and reason, we could instead directly train the LLM to think and reason all by itself by updating its weights? DeepSeek offers a reasoning model and a paper that goes into detail for how they trained it, which we will go over. So when it comes to training a reasoning model, what is an obvious but expensive approach for training? Well, we could have humans create data for training a reasoning model that would directly tell the LLM exactly how it should reason. So maybe the real human beings will create this data and say, okay, when you reason, you should do 4 steps. In step 1, you do 8 times 10. In step 2, you do 2 times 15, and so on and so forth. But this would take significant human labor and time, and this could get expensive. So what's the alternative? Reinforcement learning. So what is reinforcement learning? Now, reinforcement learning could be a video all by itself or even a course all on its own, but we will do a crash course on reinforcement learning in one slide. So let's get started. And there will be a wall of text. In reinforcement learning, a model learns through actions within an environment and receiving a positive or negative reward for its actions. In short, the model learns through trial and error. And so, why would you want to learn through trial and error? Well, reinforcement learning is useful for complex environments with unknown rules, many rules, and or rules of high complexity. So, what are some examples? Example 1. While you could set some basic rules for a self-driving car, like stop at a red light, what happens if you encounter rare situations such as how do you merge in traffic with a broken traffic light during a hurricane with animals and pedestrians running behind you and to your left? With reinforcement learning or learning through trial and error, the self-driving car can learn how to deal with this rare situation by taking actions and observing its rewards, positive or negative. Another example of where trial and error reinforcement learning would be really useful. We want to teach a robot arm to pick up objects and place it in a bucket. Programming rules for every possible object, shape, size, weight would be difficult. But with reinforcement learning, the robot arm could learn to pick up objects and place it in a bucket through trial and error with a negative reward for damaging objects or not being able to place the object in the bucket. So this is a wall of text, but what I want you to remember about reinforcement learning is what I have bolded. In short, the model learns through trial and error, and reinforcement learning is useful for complex environments with unknown rules, many rules, and or rules of high complexity. So now that we know about reinforcement learning, let's talk about the rewards used by DeepSeek. It has an accuracy reward, which is reward the LLM for having the correct answer, and a formatting reward, where we reward the LLM for placing its reasoning steps inside of think tags. Now, when I first learned about the formatting reward, I thought to myself, what's to stop the model from trying to cheat the reward system and just, well, place like filler text, like ABC123 inside the think tags instead of actual reasoning steps? But what happens is that the accuracy reward will be what measures how good the reasoning steps are in the think tags. And the formatting reward is to push the LLM to have reasoning steps. Now, in this video, we talked about LLM reasoning models, chain of thought prompting, reinforcement learning, and it sounds really complicated. But at the end of the day, this LLM reasoning model is still this simple diagram behind the scenes. We have a model with weights, and the weights can be thought of as like the brain cells or like the knowledge of the model. The model will generate outputs like reasoning steps and the answer to the question. We use an error/loss to tell the model how good or bad its outputs are. That error/loss is used to update the weights. So hopefully our reasoning model has better weights, so it has better reasoning steps and better answers to have a lower error/loss, and the cycle continues until hopefully we have really good weights for our reasoning model. So again, like it can seem like this is a really complex topic, but behind the scenes for a LLM reasoning model, this is still the core idea of what's going on behind the scenes. Let's talk about the DeepSeek or DeepSeek's reasoning models aha moment. While the LLM is reasoning, the LLM is able to reevaluate and make changes to its reasoning if that is more likely to get the correct answer, similar to humans. So if we go to the DeepSeek paper, it's trying to solve like this math problem, and in the middle of its reasoning, it suddenly thinks to itself or says out loud, wait, 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 that's an aha moment I can flag here. Let's reevaluate this step by step to identify and blah, blah, blah. So what makes this aha moment so special? The LLM learned self-assessment on its own just through reinforcement learning or trial and error. The LLM did not learn self-assessment from having humans create data that said, okay, first you try to solve this problem with reasoning step A, but then you realize that doing reasoning step B would be better. It's not like humans hard-coded uh, the DeepSeek reasoning model to think this way. It was not hard-coded. Just by trial and error, reinforcement learning, the reasoning model learned on its own to correct itself or like have an aha moment. So yeah, again, just using a reinforcement learning reward system rather than directly telling the LLM what its reasoning steps should look like, the LLM learns reasoning and self-assessment all by itself, which leads to the LLM having much more correct answers on reasoning questions such as math or logic. And we can do a live demonstration of DeepSeek. So I'm on the DeepSeek website, I create an account, and yeah, I gave it the same problem that we talked about earlier in this video, and it gives us the answer. But it also generated reasoning steps, which it says it thought for 9 seconds, and here are the reasoning steps it went through. So one thing I also want to point out is that reasoning models use more computation. When the reasoning model generates its reasoning steps, as we see here, it is producing more tokens or more words, and therefore using more computation compared to a non-reasoning model. Put simply, reasoning models use more computation and therefore cost more money in order to generate its reasoning steps, which then leads to much more correct answers on reasoning questions such as math or logic. Or another way I like to think of it is, well, reasoning models use more computation, they cost more money, but they get better results. Nothing in life is free. And when using a LLM, the LLM provider may only let you use its reasoning model a limited number of times and or only if you pay extra. So, when to use reasoning models? Reasoning models are best used for reasoning questions such as math or logic, as obvious as that sounds. So, for example, using reasoning models for factual questions such as what year was Abraham Lincoln born in would waste computation and therefore waste money. And to conclude this video off, reasoning can be thought of as splitting a problem down into smaller problems that are easier separately, similar to what humans do to get better performance. By just using a reinforcement learning reward system rather than directly telling the LLM what its reasoning steps should look like, the LLM learns reasoning and self-assessment all by itself, which leads to the LLM having much more correct answers on reasoning questions such as math or logic. And in case you're wondering why should I care about reasoning models, well, having models that can think and reason could have massive benefits for us in the future, such as finding cures to diseases, finding new discoveries for technology, etc. All right, that's it for this video. Thanks for watching. See you all in the next one.